Good evening, student. Okay, so let us start our first chapter. So the chapter name is Electric Charges and Fields. Let me write the heading. Fields. So okay, let us take a real life example. Okay, consider a scale. Okay, you have seen it in this real life. Okay, you know the scale, right? Plastic scale. Okay, and take some bits of paper, small bits of paper. Okay, it should be small. Now rub it to a head, rub it to a hair. Okay, and keep it closer to it, to the bits of paper. What happens? The paper will start to attract the scale, right? And you know this, what is this phenomenon is? Okay, it is static electricity. Static electricity. Okay, now why it is, what is the reason for this? Okay, why does it happen? Okay, so this is a question mark, we don't know it, correct? Okay, the reason behind this is a entity called charge. Okay, if the charge didn't exist, then this phenomenon wouldn't occur. Okay, so now what do we know about charges? Okay, is charges easy to explain? How can we define a charge? Okay, so there is no formal definition of charge. Okay, nobody knows what is charge. Okay, what is charge, how it came, we know nothing, but we know something about it. We know some properties of charge, how it interact. Okay, so see, there are two types of charges. We don't know what it is. Okay, but see, when doing some experiment, some charges attracted together and some charges repelled, wanted to go far as possible. They are not like friends, they are enemies. Some charges are like friends. Okay, they want to come close together. Some are like they want to go far together. Okay, so after conducting many experiments, scientists figured out there are only two types of charges. Okay, so now see, what is a charge? Okay, it is not easy to explain. So it is an intrinsic property of material, property of particle. Okay, so it's like this, it's like it has no some definition. So let's see this about conductor. So material, there are conductor, insulator, and okay, so conductor conducts the electricity. So our houses have wire, and wire are used in switches, board, in electronic devices, everywhere. Why? Because it conducts electricity. And there are some insulator. Okay, and insulator do not conduct electricity. So what might be the reason behind it? Again, it is charges. Charges are the reason behind it. Okay, so let's see how we can produce a charges. Okay, there are basically two methods of inducing charges. One is by friction, charging by friction or rubbing. Okay, so what example I have given was for static electricity, it is rubbing a scale. So while rubbing the scale towards any other object, okay, or hair, what happens? The electrons are ripped off from one material and deposited to another, or the particle, the charges are ripped off from one material and deposited on another. Okay, so this is one method. Then another method is charging by induction. So in this method, what we do is we take a charged object, already charged object. Okay, and so consider this has only positive charge, and we keep it close together with another object. This works only in the case of metals. So what happens? It induces its charges. So some of the positive charges are So here negative charges are induced, okay, and here positive charges are induced. So see, the positive and negative charges attract together, so that's why in this region you can see negative charge induced in this region. Okay, so this much you have understood, I think. Okay, then let's see the basic property of charges. So see, charges, we can't see charges individually charges, but see, by some experiments we can determine the property of charges. So see, first property of charges is charges are additive in nature. Okay, so you can add up the charges. So if you have 1 coulomb, see, if you have plus 1 charge, then if you have another plus 1 charge, if you have minus 1 charge, you can add this together. So plus 1 plus 2, 2 minus 1 is 1. So charge is plus 1 again. Okay, so charges are additive in nature. So generally you can say like this, plus q charge, if you have minus q charge, plus q charge, you can add those. Okay, charges are additive in nature. Second one is charges are conserved. So see, nobody in this earth, okay, not anyone, not any human can create a charge or destroy a charge. Charges can neither be created nor be destroyed. Okay, this is very essential property. So if that was possible, then the laws of nature wouldn't apply. Okay, charges are neither be created nor be destroyed, they are conserved. Okay, so another way of telling this is, see, if you have a positive charge over here, somewhere in other part of the universe there should be a negative charge. For each positive charge there should be a negative charge, or else the law of equality is not obeyed. So this is most important thing you have to know. Then the last one is quantization. Charges are quantized. So what do you mean by quantized? See, if you go to a shop and you ask for a vegetable, okay, you just ask for an apple, so he will ask you how much kg you want, how many kilograms you want. You can tell half kg, or you can say 1.5 kg, you can say 1 kg, correct? But if you go to shop and ask egg, okay, how you should ask? You want how many eggs, right? You can say 1 egg, 2 egg, or 6 egg, or 12 eggs, correct? 1 dozen of egg, or half dozen of egg, correct? So 1 dozen means, so like that you are asking. So see here, what you can observe, in case of apple you said 1.5 kg, correct? In terms of egg, see here you cannot ask 1.5 egg. So if you ask 1.5 egg, you should destroy the egg, correct? And that is not possible, charges cannot be. So this can be applied for charges also. So charges are quantized. So what it means, charges exist in whole number. There is nothing like half charge, half positive charge, no, nothing like that. So charges are always quantized, and that formula is given by Q is equal to Ne. So where N is number of charge and E is charge of electron, and there is charge of electron or positron. So now see, proton or any charge, okay, now there is a value for E is charge of electron. The value of E is 1.6 into 10 to the power minus 19 coulomb. And see, this unit is very important. So coulomb is SI unit of charge. SI units, International Standard Unit of Charge, is coulomb. So I think your concept of charges is clear by now. So you have basic idea what the charge is, how it interacts with other charge, how it interacts with the material. So by this I conclude my class. Thank you for opportunity.